Hi, Algebra 1. Today we're going to continue working through the lesson about solving quadratic equations. And so this is the second part of 9-4. We're just going to add one extra little dimension today, and then we're going to do a pretty common form of a geometric word problem that involves solving quadratic equations. So today you need to have your books open to page 556 and at least have looked at the note handout for today and have something to take notes with. And we're going to start right here with this type of problem right here. 4x squared minus 21x equals 18. Now last week we started learning how to solve these and the reason behind it, and that was based on the zero property. That if we have two or more things multiplying together to give me a product of zero, that means one of the two has to equal zero. So we also touched on the fact that quadratic equations can give me up to two possible solutions because it's x squared, so we have two possible solutions there. Well, today we're going to keep moving in the same process, but one more thing that we need to add, and if you look at this problem in the form that it is, I need to acknowledge that it's not ready to solve yet. I need to have my quadratic equations in standard form. That means it's going to be an ax squared plus bx plus c equals 0. So I need everything moved to the left side of the equation. And in this case, I have it equal to 18. So I can't start yet. So the first thing I'm going to do is use some of my equation properties or my techniques to solve equations and move everything over to the left side and get it into descending order. So the first thing that I'm going to do is subtract 18 from both sides. Remember, for equations, I can do anything that I want to them as long as I do it to both sides. So I'm going to keep my equal sign lined up, and 18 minus 18 equals 0, which is the point of what I'm trying to do. Now, if I write this quadratic equation in descending order, this is what I have. And right now, we'll pick up to what we learned last week. How do we solve this? Well, the first thing that I need to always look for is to see if I have a greatest common factor that I can factor out. And in this case, I can't. They don't all have an x, and all of the numbers are not divisible by either 2 or 4. So that means I need to solve it in the form that it is. This means I need to recognize that I have a lead coefficient other than 1, and so I'm going to need to use one of my two shortcut methods, either divide and slide or the greatest common factor table. But no matter which method I choose, I know I have to use my x form first to get started. And so I will demonstrate this one using divide and slide. So here is my x form. I'm going to write it kind of small so that we have enough room here to finish the entire problem. My a term times my c goes in my ceiling. And 4 times negative 18 is negative 72. My b still goes in my basement. So what my first step is to figure out the skeletal form of my binomials. I need to think of two numbers that multiply together to get me negative 72, but add together to get me 21. And 72 has a lot of factors, but if I know when I add them together I get negative 24, that means that they're actually going to be kind of far apart because one of them has to be negative. So if I go for this, I know 24 times 3 is 72. Now it's just a question of figuring out which one's negative. And in this case, my 24 will be negative. So my first step, I'll use a different color marker so that we can keep our steps separate. My next step then is to set up my binomials. X minus 24 times x plus 3. Now remember, right now, I'm not done. If I were to FOIL this out, I would not end up at 4x squared. So I know I'm not done. The part that comes in with the name of this shortcut method, divide and slide, I need to divide my numbers by my lead coefficient. So I'm going to divide both of the numbers by 4. And remember from our previous lessons, we should really call this divide, reduce, and slide. So the next thing I'm going to do is simplify. 24 divided by 4 gives me 6. 3/4 does not reduce any further. So that means I have a denominator that I will now slide. Divide, reduce, and slide. So this 4 comes to the beginning of my binomial. So my final answer for this, as far as the factoring, sorry, it's not my final answer yet. My factoring is this. And remember, all along, this was an equation set equal to 0. Well, this is where my 0 property comes in. That means this quantity has to equal 0, or this quantity equals 0. So I break those parentheses, those binomials apart, and set up two mini equations. That means x minus 6 equals 0, or 4x plus 3 equals 0. I know I'm getting to the bottom of this board here. If I use my equation solving properties here, I get x and negative 3/4 as my two possible answers to this quadratic equation. Okay, at this point, I want you to try one practice problem. You will see it on the note handout if you are looking at that. It's also taken from your book. I'm going to clean my board though and write it down for those of you who are just taking notes on paper. It's the Got It problem under problem 3 in section 9.4. This one's a little bit easier. Okay, here's our quadratic equation. X squared plus 14x equals negative 49. What I want you to do right now is to go ahead and pause the video and solve this using all the steps that we've learned so far. Taking what we added today to what we learned last week. So go ahead and pause this video and then come back when you're ready to go over it. First thing I need to do is I need to get everything on the left side of my equation. I need it to be in standard form. So to get there, what I'm going to do is I'm going to add 49 to both sides. Now, if I'm lining up my equal sign and I have it set equal to 0, I know that I at least did the right thing because that's my goal. I want my quadratic equation to be equal to 0 before I move forward in this process. Now notice I'm adding 49. Well, 49 is only a like term to other numbers. This one has x squared, this one has x. My 49 doesn't have x at all. So it's my C. So this is my quadratic equation. X squared plus 14x plus 49 equals 0. Now my next step to solving this is to factor it. I need to do one of two things here. I need to use an X form and put 49 in the top. I'll demonstrate that over here. And my B goes in the bottom. And if I do that, I know it has to be 7 and 7. Another method that we've learned is to recognize that I have a perfect square trinomial here. X squared is x squared. 49 is 7 squared. And if I notice that it's my A times my B, 7x doubled, that tells me that I have a perfect square trinomial. And this is what I have. I would have gotten that using my X form as well. Now notice something about this. I have one binomial being squared equals 0. We've been used to getting two possible answers. Well, remember I told you that a quadratic equation can have up to 2 answers. It can also have one answer. And in this case, if I'm squaring the same binomial, that means x plus 7 equals 0 or x plus 7 equals 0. There's no need to write it twice or solve it twice. It gives me the same answer each time. I get as my answer for this problem, negative 7. I don't need to say x equals negative 7 or negative 7. It's the same number. So here's my one solution to this quadratic equation. Okay, the next problem that we're going to do is problem number 4 from this section. And I have the picture written on the board, but I want to refer you to your book on page 557, problem 4, just to get an idea of what this problem is telling me. I have a picture, a photo, that is 11 by 17. And then I have a frame that has a certain width. It's the same width all around. I don't know what that dimension is of the frame, but I do know that my total area for this rectangle is 315 inches squared. Okay, so I need to backtrack a little bit and just remember that the area of a rectangle is my length times my width. Well, if I have an unknown here, I don't know what the width of this frame is. This is taking us back to a similar problem we did a couple weeks ago where we were trying to find the area of a walkway around a patio. Well, the same concept applies here. If I wanted to know the length of this frame, I would take the 17 inches that I know, and then what is being added to it is x. I don't know it, but I know it's x. And then x. There are 2 x's being added. So my length is actually 2x plus 17. If I want to look at my other dimension, I'm going to know that my photo is 11 inches plus x plus x. So that would look like this. And what's my length times my width? Well, it's 315 inches squared. Okay, so now I have the basics done, but I can't just say, well, this needs to be 0 or this needs to be 0, because it's not set equal to 0 yet. I need to do a little bit of math work before I can solve this. And so the first thing that I need to do is actually FOIL the 2 binomials that I have here. And we're going to definitely run out of space here on this whiteboard. That's okay. We'll get in what we can, and then we'll erase and give ourselves more space. So the first thing that I'm going to do is I'm going to FOIL it. My firsts, 2x times 2x, gives me 4x squared. My outsides are 22x. My insides are 34x. My lasts would give me 17 times 11, and I've already done that, is 187. And what does that equal? 315. We were already told that in the problem. Well, just like we did in our previous problem and practice problem, my next step is to actually get this into standard form. I don't have it there yet. I don't have everything on the left side of my equation set equal to 0. And I also see I have 2 common terms that I need to clean up. So I'm going to go ahead and do that. I'm going to do it in the same step. I know I'm going to have to subtract 315 from that side to get me 0, which means I need to subtract 315 from the left side. Keeping an eye on my equal sign to make sure I'm not losing any parts of my equation. So 315 minus 315 gives me 0. 4x squared plus 56x when I combine those common terms. And then 187 minus 315 is negative 128. All right, you can tell we're at the bottom of our work area here. I'm gonna go ahead and erase this and rewrite it again to show the factoring part of this problem. Okay, so we had 4x squared. Once I have that in standard form, this is where I am. Well, at this point, I need to go ahead and factor it. The first thing that I need to get in the habit of seeing is seeing if I have a greatest common factor that I can take out, and I do. All of these numbers are divisible by 4. So if I pull a 4 out, I am left with this. Once I take that greatest common factor out, it leaves me with a much easier factoring problem. And I also noticed that I have a lead coefficient of 1, which means I don't even have to use any of my shortcut methods other than the X form. So it's really sweet when that happens. So let's just go ahead and make an X form. My AC goes in my ceiling. In this case, it's just -32. And my B goes in the basement, so that's +14. So I need to think of two numbers that multiply together to get me -32, but add together to get me 14. Well, I know 16 and 2 give me 32. And if I make this negative, then let me clean that up. It satisfies multiplying to get me -32 and adding to get me 14. So if I were to write this again in a factored form, remember my greatest common factor stays out front. And then my binomial looks like this. My two binomials look like this. Well, using my zero property, that means anything that I'm multiplying together, each of those components could equal 0. One of them has to, for sure. Well, notice I have this 4 out front. That one can't equal 0. 4 cannot, in any world, equal 0. So that means I'm going to set up my two mini equations with this binomial and this binomial. So I get these answers, and I know we're doing a little bit of mental math here. That means x equals either -16 or +2. Well, if we're just doing a math problem, I could have two possible answers there. However, we're not just doing a regular math problem. We are trying to find the width of the frame around my photo. So that means actually one of these answers can't even be possible. Which one is it? Well, this -16. I can't have a -16 as the measurement of a width of a picture frame. So common sense will eliminate that as an option. So that means the only possible answer is 2. If you were referring to the problem in the book, though, it was asking for the dimensions of the photo and the frame. So that means I'm going to have a 17 plus 2 plus 2, which gives me 21, by an 11 plus 2 plus 2, which gives me 15. So the answer for this first problem, the dimensions of this picture and the frame are 21 by 15. Okay, now is where you get to pause the video and try one. I'm going to clear this, but the problem actually remains very similar. It says to solve this same exact problem, but instead of 315 square inches being the total area, we're given a new scenario. The new scenario is it's 391 square inches. So a lot of the work that you just did for problem 4, you are going to be able to use again. I want you to pause this video and try this problem under the new conditions that the total area equals 391 square inches, and then figure out the dimensions of the photo and the frame, and then restart the video and we'll go over it together. Okay, I'm gonna go ahead and I'm gonna dive right in. I'm not gonna feel the need to explain every step of the problem because we just did everything in problem 4. We already said that the dimensions of this rectangle, even though I don't know the width of the frame, I do know that the width of the frame is x. So that means my total length was 2x plus 17. My total width was 2x plus 11. And I know that it tells me that it equals 391 square inches. So I'm going to go ahead and FOIL the two binomials that we have, but you'll notice we already did that. So I'm actually going to just look back to problem number 4 and say, well, that we were at 4x squared plus, let me get it right, 56x plus 187 equals 391. Well, as we learned today, I can't solve this the way it is. I need to get it into standard form. That means I need to subtract 391 from both sides so that my quadratic is set equal to 0. Once I do that, and I already did the math. It's minus 204 equals 0. Now that it's equal to 0, I'm ready to factor. Again, I can see that I can pull out a greatest common factor of 4. And that will leave me with x squared plus 14x minus 51 equals 0. Now, once I took out that greatest common factor of 4, the quadratic that I'm concerned about factoring is what is inside the parentheses. Noticing again that I do not have a lead coefficient of 1, or I do have a lead coefficient of 1, so I can just use an x form. And if I do that, this is what I get. Going a little bit faster this time. This is my factored form of that quadratic. So that means x minus 3 equals 0 or x plus 17 equals 0. So that tells me that x equals positive 3 or negative 17 when I set up those two mini equations. Well, just like we discussed in problem number 4, I know that negative 17 can't be the measurement of a real life object. It has to be 3. So that means in this problem, the width of the picture frame is 3. So I have 3 plus 17 plus 3 gives me 23. And my width is 11 plus 3 plus 3. So I have 23 by 17 are the dimensions of the frame in this problem. Okay, so we just added one little extra element to today's lesson, building on what we started learning last week. That's it for today's lesson, and that's actually it for everything that we're going to cover in Chapter 9. So this, along with the end of Chapter 8 with our factoring, will be on the quiz that's happening this week. I will be sending out information about that, and we'll also be talking about it in detail during our Zoom class on Tuesday. So come prepared to hear more about the quiz. You have suggested book problems written on the note handout, as well as on RunWeb, and you have one Khan Academy assignment that tests you on what we just learned today. Okay, that's it for today, and I will see you next time as we dive into Chapter 10. Have a good afternoon.